We are now zooming back into that zone where we've got the fault. So what I try to represent here is the line of section here, and we've got the different faults. So we've got the Brockley fault here, we've got the North Hill fault, we've got the Cleve fault here, and the Rington Hill fault here. So for 3 of them, we've got the tick marks here for the Brockley fault. Here for the North Hill fault. We don't have any for the Cleve Hill, we're going to think about that. And then for the Rington Hill, we've got a tick mark just between the G and the T in Rington that tells us that part has gone down. So if we assume these are normal faults, then this one will be dipping south, this one will be dipping south, this one will be dipping north. If we assume we are reverse fault, it will be the opposite. What about the Cleve fault? Well, what we can see is along the line of section, this fault is putting D1B on the north side in contact with this GCO and GUO, which are part of D2. So D2 is younger than D1B. This means that if the rocks are younger on the south side than on the north side, then the south side has gone down. So we're bringing all the rock closer to the surface on the north side. So what does that look like on our line of section? We've got our line of section. Again, we're going to have some sort of relief. We've got the north, we've got the south. Well, it's fairly homogeneous. So we say this fault is going to be dipping south, like that. This fault is going to be dipping south as well. This fault is dipping south as well. And this fault is dipping north. So we're going to have something like that. Now, what are the rocks in between doing? So let's start with the south side because we've got good constraint here. We can see that we've got D2, we've got the blue here, which is another D2, I think. And then we get into D3, the light blue here is D3. The rocks are dipping at an angle of 20 degrees. So here we are 20 degrees towards the south. So all rock units, we're going to think about what they are dipping this way. Here we've got D2 here, and we've got somewhere D3 further up. Between these two faults, you've got an arrow here that indicates a 10 degrees towards the west, which means that it's practically perpendicular to our line of section. So these rocks are going to appear roughly horizontal, and that's why, for example, we've got GCO, which is a relatively small unit, appearing quite broad here. So here we have D2, and GCO is somehow near the bottom of D2. So we're going to have units that are going to be, again, they will appear nearly horizontal. And yeah, I guess I should have done my topography a bit more. But you're going to have to give them a dip to be able to... so we said this is going down here. 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 So we're going to have to give them a dip so that we can put the contact. So we've got here, so this is D2 we said, and we've got GCO. So if that block has gone down, then the contact here will bring D2 further down, and GCO is somewhere here. So these rocks, you will see on your topographic profile, you will be able to make these units fairly horizontal in that case, and have that contact appearing in the middle. As I said, we're not representing what's right in the middle because it's a bit too complex. We get in that part, and here we've got units that are dipping somehow 14 degrees towards the south, so still not a very steep angle, but the rocks are dipping towards the north now. So we're going to have here, as we said, we've got D1B, which appear at the very bottom here, and we're going to have to put a sort of angle if we want to be able to put D1B here and then below D1B we're going to have D1A, and so on. So the rocks are going to dip somehow. So the rocks are going to be nearly horizontal here, dipping south here, dipping north here, and then on that last part we're having, what are we having? The rocks are dipping like 20 degrees in that direction. So again, you will be able to represent the different units at a dip of 20 degrees this way. Make sure when you draw your rocks that the offset appears correctly. Then we get at the end here, and that's where we said we have our Triassic, the D2 that pokes through the Triassic. So this is Triassic here, and then underneath we're going to have the units. So this is basically an anticline, but the anticline is affected by this normal fault just near its apex. And I guess this is some, you could think about how did that happen in a compression setting. Well, it is possible when you've got rocks that are fairly brittle, that when you bend them, when you fold them quite tightly, then they will break on the outside of the fold. So it's almost like it's like tension cracks that appear. So when you take a layer horizontal, like a layer, and you start bending it, you will see, we will see that in some of the lecture, like near the middle you're going to have compression, and on the outside you're going to have extension just by the, you're going to stretch the back of your anticline. So these normal faults may be associated with that, or it may be something more general. That's what we have here. Okay, so the next step now that we've got a broad sense of the structure in this area, now we're going to have to build our cross-section, build our folds, build the units that are under the Triassic. What we're going to have to think is about that Carboniferous succession in particular. And something that you may have noticed, and if you haven't, then you should pay attention to that now, is that actually there are changes that operate at that scale in terms of the different units that are exposed. So just to illustrate that here, you can see that, so the D1, we've got D1A, D1B, we find D1A, D1B on the other side. Here we've got the Brington oolite, we find the Brington oolite. And then we've got the CD1 here, and then we've got the Cheddar oolite. And the Cheddar oolite doesn't appear on the other side. Similarly, here in D2, it's D2 which is the main unit that shows this variation. We find units here, like the GCO, GUO, that we don't find here, despite being of the same age. So have a wee think about why that may be the case. Look at the stratigraphic succession here, they may tell you something about it, and then think about how you're going to represent that in your cross-section.